In this video, we're going to learn about doing easy Metpy calculations and how we can add them to our datasets and plot. And so if you're following along in the handout, we are now at part 2, easy Metpy calculations on page 4. And so for this video, what we're going to want to use is our Metpy calculations wind speed notebook. And so we're going to go ahead and make a copy of that through duplicate, put that into our working directory, and then from our Metpy calculations here, rename, and say that is the wind speed calculation. Let's go ahead and give that an open. And one of the things we're going to want to note here in our Metpy calculations import cell is we've got this relatively new line. So in order to bring in the calculations that are available from Metpy, we need to import them to make them of use in our notebook. And so this import metpy.calc as mpcalc is what is doing that. And basically what we're doing is we're adding all of the different calculations functions that are available from Metpy. And clicking on this link will allow us to see them. And so you can see that there are a whole host of different variables that you can plot. Now, some of these functions will work for our gridded calculations as from the GFS. Some won't, as they are meant for more point data on soundings. We'll get to a few of those in a future video. But the one that we're really concerned about today is under dynamic and kinematic functions. Specifically, we want to calculate the wind speed. Wind speed is a critical variable because it helps us to identify regions of fast-moving air, better known as jet streams. And so this documentation page tells us a little bit about how this function actually works. And so what we see is that there are two parameters that go into the function: the u component to the wind and the v component to the wind. And that's going to be important for then how we're going to be able to successfully do this calculation. Back to our notebook now. Let's go ahead first and run our cell that does all of our inputting. Whoops, we got our error, no module named Metpy. That's because we haven't run this notebook before and we haven't switched our kernel to be Valpo Spring 2020. Getting that done, let's go ahead and rerun this cell. There we go, we overcame that error. In this next cell, we're going to go ahead and read in some data. We're still reading in GFS data here, but we've changed the source. The source is now NCDC, and we are looking at the GFS analysis files. And so the GFS analysis files are simply they only have the model initialization time. And so this is great because that means there is exactly one time available within this file. That will make some of our calculations easier, and we won't have to subset for time. So we're going to pull in some data from March 23rd, 2020 at 12 UTC. And we're going to set our plot time as the date, since we know we can only have that one date. And then subset for our US region. All right, so this isn't all that different except for the different web address to get to this data. But now to go do our calculation, we're going to need to develop a couple of pieces. And so first here, we want to calculate the wind speed from our variables that are available within our dataset. Specifically, from our dataset, we need our u component of the wind at pressure levels and our v component of the wind. And those are our two inputs into the wind_speed function from the Metpy calculation module. We're setting the result of this function, which is going to be a unit array, equal to the variable WSPD, which is short for wind speed. Let's go ahead and give this cell a run. It runs relatively quickly, and now we can go ahead and print the output of the variable WSPD, and we're going to see it's basically just a big array that has units attached to it. And so the units of our wind speed from our model output is in meters per second. So this is great. This is great for so many reasons. all of the calculations in Metpy have units associated with them to make sure that we do things correctly. Once you get to dynamic meteorology, you're going to be very thankful that Metpy has units attached to things. We can go ahead and cut this cell since we don't need it. We just wanted to look at what was going on with the wind speed. But now we need to do something with this wind speed calculated variable to add it back to our data set. And so from our data set, we have this function called assign, where we can assign a new variable and put it into our data set. And so we're going to do that, and we're going to name our new variable within our data set wind_speed. Now we're going to do a little sleight of hand since we can't do this directly, and initially set wind_speed equal to a variable already from our data set. And since we know wind speed is largely like one of our wind components, we're initially going to set it to ds u component of the wind isobaric. This is going to bring along a whole bunch of metadata, which is going to be critical for plotting purposes. And then once we have this new variable assigned, wind_speed, in our data set, we can then simply update the values. And so here we're updating just the array values. And we can do that then by setting it equal to WSPD and the magnitude. So we're stripping off those units from our unit array to plug in just the values into our data set. So let's go ahead and give this a run. That runs relatively quickly because it's just in memory here for a single time frame. And we could even see what that looks like by looking at ds.wind_speed. And sure enough, now we have our full data array. We have values that do appear to be in knots, or in meters per second rather, with all of the metadata associated with it. I'm going to go ahead and cut that cell just to reduce that overhead. And now we want to move on to our plotting. Since we added wind_speed to our data set, we can simply call that wind_speed variable for our field, specify the level we want to plot, 300 millibars, using our plot time since we still have the time variable associated with it since we did not yet subset. And we can set up our range of values for plotting meters per second, starting at 10, going to 100 by 10 meters per second, using the color map BU or blue-purple, and a horizontal color bar. With the wind speed, we're going to plot our geopotential height_isobaric at the same 300 millibars, using 120 meter contour interval. And we're going to plot them in black solid contours. Adding both then to our panel, and our panel to our plot, we can go ahead and see what our 300 millibar wind speeds look like. And here we go. We now have our beautiful upper air plot where we can see a bit of a trough ridge pattern going on with a strong jet stream here in the southern tier or across the center part of the country, probably the southern extent of a polar jet stream. But remember that these winds are in meters per second. What are the units we typically plot wind speed in on our upper level maps? That's correct. Typically it's knots. Now, we could do a simple calculation and multiply our wind speed values by the correct conversion rate, and before entering it into our data set. Or, since we have units associated with our data array, we can say cfill.plot_units equal KTS, short for knots. If we go ahead and run this, we're going to find we probably max out our values here because now we're in knots, so we've about doubled what the meters per second value were, but we didn't change our contour levels. So let's go ahead and change that. Let's start at 30, and let's go to 201 by 20. And here we get back to something that is very similar to what we had before because we about doubled it. But we could even change other things if we wanted to. Since we don't quite have that fast of winds, maybe we go to 151, but maybe we go by 5 knots. This will create a bit more of a gradation in our values and get us a different looking plot. One is not necessarily better than the other, but this is the choice you get to make as the map maker. So we can see that using simple plots from our doing simple calculations from Metpy allows us to do these nice simple plots still, without too much worry. In future videos, there will be information about how we can do advanced Metpy calculations. Advanced calculations are not going to be a part of the official content for this course, but is there if you are interested to seek further information and do more complex things in this environment. Thanks for watching. Hope you have a good day.